Alright guys, here we are on the second day of 11.2. We're going to talk about a different shaped surface area. Today we're focusing in on a cylinder. So a cylinder is a solid with two circular parallel bases. So the difference between yesterday and today is that now these have circular bases. So if we were in class, I would have a whole demonstration with you with a soup can to talk about the difference between the lateral area and the area of the bases. If we thought about the bases first, when we look at a soup can, the bases of a soup can would be the top and the bottom. The top and the bottom happen to both be circles, so to find the area of the base, we just use the area of a circle formula. So that's fuzzy wuzzy was a bare area equals pi r squared. But since there's two of them, it's going to be 2 pi r squared. So that gets the two circles. We'll label that. That's r right now. And then the lateral area is what I would have you, if you looked at a soup can, the lateral area is the area of the rest of the cylinder. That would be this soup label here. So if I looked at this, and I took that soup label, and if you wanted to try this at home, you could, and broke it apart, we actually end up with a rectangle. If you think of unwrapping that, that ends up being a rectangle, where the bottom part of the rectangle is what goes all the way around the circle. So that would actually end up being the circumference. This is 2 pi r. And then the height of the cylinder is actually the height of this rectangle too. So we're going to call that h. So that's where the lateral area comes from. So just a little lesson on where the parts come from. But that's now your surface area formula is 2 pi rh plus 2 pi r squared. Where r stands for the radius and h stands for the height, which is still going to be the line that connects the bases. So it's not always going to be up and down. Sometimes it's going to be sideways, and you're just looking for that line that's connecting those two circles together. That's how you know you have the correct height. Alright, so we're going to try a couple examples on the next page. We want to find the surface area of these cylinders. Note that we are leaving them in pi form. So for anything that has pi in this chapter, we're going to try to leave it in pi form when we're doing the geometry problems. So looking at number 1, we need to find the two parts that are in the formula, which are r and h. R is the radius of the circle. So if I focus in just on the circular base here, the radius is 5. H, you can think of the same thing we did yesterday, is the distance between the two bases. So it's the line that connects the two circles. H is 4. It won't always be straight up and down. In this particular one, it's sideways, but it's always the line that connects the two circles together. So then I'm just plugging into the formula. The formula says to find the surface area, it's 2 pi RH plus 2 pi r squared. And then you're going to simplify the multiplication part first. So I'm going to multiply the 2 times the 5 times the 4, but I'm going to leave the pi in the answer. So this would be 40 pi. And then I'll do the same thing here. I have to square 5 first. Make sure you follow your order of operations. 5 squared is 25 times 2 gives me that this is 50 pi. And then I can add those two together and get my answer is 90 pi feet squared. Alright, looking at number 2, again, the first thing you need to know is the radius. That will always be on the circle. So if you find the circle, we have to figure out the radius. They gave me the diameter is 14, which means the radius is 7. So r is 7. And then h is that line connecting the two circles together. H is 16. So to find the surface area, that's 2 times pi times RH plus 2 pi r squared. So that's going to be 2 times 7 times 16 first. Just don't type the pi in your calculator. That's 224 pi plus 49 times 2 is 98 pi. And then we can add those together. We get 3 22 pi centimeters squared. All right, the last problem we're looking at, we're getting more into the word problem aspect of this. There's lots of implications for this chapter in terms of the real world. If you're trying to paint something in your house or trying to fill in a garden bed, there's all sorts of things you can do with surface area and then with volume later this chapter. So looking at number 3, it says you have a cylindrical flower container that you want to paint yellow. The container has a height of 12 inches and a diameter of 18 inches. How many square inches of paint do you need for this project round to the nearest tenth? Note the flower container does not have a top, so the top will not be painted. So I'm just going to draw this out. And you can actually see how you could draw it out yourself. Is I just draw 2 ovals and then I connect them together. And that's how I make a cylinder. So we know that the height of it is 12 inches, so that's 12 over there on the side, and that the diameter is 18. And we were trying to figure out how much paint we needed, but the key here, you've got to pay attention to this, is now we're in the real world, is sometimes some parts of it might not be painted. There's no top to this, it's just an open cylinder, so the top's not going to be painted. So let's write out the formula. 2 pi RH plus 2 pi r squared. And what I like to do is I like to first, just looking at the formula, thinking about what that means I need to take off. If the top's not going to be painted, the top happens to be a circle. So instead of having 2 circles in the formula, I just want 1. So this is, since that's not painted, we need to take off one of the circles. The circles is this part of the formula. We're just going to cross this off and say instead of 2 circles, I just want 1. We're going to change that to a 1. And then we can just answer the question like we did before. We're going to fill in the formula. The radius is 9, and the height is that line connecting them. The height was 12. So we're going to plug that into the formula. 2 pi times 9 times 12 plus, we're just making this a 1, pi times 9 squared. And now for this particular problem, we are going to round to the nearest tenth. So you can put pi in now, or you can put pi in at the end. I tend to put it in the end. So I'm going to do 2 times 9 times 12. That's 216 pi. And this is going to be 81 pi. And we get 296 pi, or 297 pi. And then again, because this is a real world problem, we actually do want to put that into the calculator. Since it says round to the nearest tenth, is we're going to put the pi in the calculator, or put 3.14 in your calculator, because it's a real world problem to answer how much paint we really need. And we're going to round to the nearest tenth, so that's 933.1 inches squared. That's how much paint we will need. Okay, so hopefully that helps. There is a word problem or 2 on the homework. You also have a couple problems to try on Class Kick next, and then you can work on the homework assignment. And I'll be answering questions tomorrow.